So the center of this lab is a flask with calcium hydroxide solution. This will serve as our carbon dioxide trap. You also see the green aerating stone, which is a porous stone, and this aerating stone will create small bubbles, small gas bubbles, if you blow some gas through it. So here you can see a close-up of the aerating stone in action. It is porous, and when air is forced or gas is forced through it, then it escapes this stone in tiny little bubbles. The smaller the size of the bubbles, the greater the surface area between the gas and the liquid state, which is where the reaction occurs. The balanced equation shows how this trap works. The calcium hydroxide that is dissolved reacts with the carbon dioxide gas to form solid calcium carbonate and water. So the calcium carbonate that is formed is solid. These small solid particles get suspended in that mixture that is forming now, and that gives you the impression of a cloudy or opaque mixture. And as more calcium carbonate is formed, these particles will sort of clump together, they will coagulate and then sink to the bottom as a precipitate or deposit on the walls of your vacuum flask. In order to measure the volume of the exhaled air that is sent through the calcium hydroxide trap, we direct the exhaled air coming from the trap into a graduated cylinder. The cylinder is filled with water and inverted and immersed in a sink so that we can displace the water inside. The volume of the displaced water in that cylinder is then equal to the exhaled air that was sent through the trap. So with the help of the graduated cylinder, we can determine how much total exhaled air we have sent through the trap. We know from other experiments that 1 liter of exhaled air contains 80 milligrams, 0.08 grams of carbon dioxide. That is how much we can at most capture from the exhaled air. It's called the theoretical yield, the maximum amount that is possibly available from this process. So we weigh our calcium hydroxide trap before sending the exhaled air through it. Then we weigh it again after we have sent a certain amount of exhaled air through. The mass that our apparatus will gain is going to be equivalent to the mass of carbon dioxide that we are able to capture from the exhaled air. Let me walk you through the calculation. If we collect 10 liters of exhaled air, if we send 10 liters of air through the trap, and the air has a concentration of 0.08 grams of carbon dioxide per liter, then these 10 liters times 0.08 grams of carbon dioxide should give us 0.8 grams of carbon dioxide as theoretical mass gain. So when we do the experiment and our trap actually only gains 0.64 grams, then this actual mass gain is less than the theoretical mass gain. So our effectiveness can then be calculated, and the measure of our effectiveness is the yield. It's how much we actually gained in mass here over how much we should have theoretically gained times 100%. The term is percent yield, a measure of the effectiveness. In this example, 0.64 grams actually obtained versus 0.8 grams theoretically obtained times 100% would be 80%. This last slide summarizes our lab in 5 steps. Read through it and make sure you have an idea of the big picture, so to speak. And have fun in the lab coming up.